Topic 7-3. This can be referenced with the Holt textbook, Chapter 5, Section 8, on page 356 through 362. Okay, they're dealing with applying special right triangles, and the first one we need to know is a 45, 45, 90. And I like how they started out by showing it as a square, because this is where we can derive this triangle that's always taken from the diagonal drawn from a square. So if you draw a diagonal in any square, you've created a special right triangle that now makes up a 45, 45, 90 triangle. Because cutting a diagonal through a square cuts a 90-degree angle into two equal parts, 45 and 45. So this particular triangle is what we're looking at. And I snapped some of my these snap legs together to show you that this can be proportionally different in size. These would be my two right angles made up by the same color, so their lengths are going to be the same. Same thing with this. If I make this triangle with two greens and a blue, it's the diagonal of a triangle. 45, 45, 90 triangle. Always the value of the legs are going to be the same. Two greens, along with the same thing would be two of my oranges. So remember that when we label the value of our sides, and those are going to be labeled with an X. So always your side lengths are going to be the same. So you might fill in the notes that I have here. You draw a diagonal, and in a square the diagonals bisect the opposite angles, making it 45, 45. Two right triangles are formed, and they will always, no matter what size your square is, form this degree angles in the triangle. Alright, you're going to label each of the legs an X. And then using the Pythagorean theorem, I just wrote it in over here, you would have your x squared plus your x squared is going to be equal to this, the hypotenuse squared. That's your Pythagorean theorem. If you take these two and add them together, that's 2x squared, and the square root of anything squared, the x becomes the outside. The 2 can't be perfectly squared, so it stays under the radical. That squaring the hypotenuse squared is my hypotenuse. So this is how they got the value of this length of the diagonal. So always is a good idea to label it. Label it on here. X square roots of 2. So anytime you see a 45, 45, 90, it's good to go ahead and just label it. These are the lengths, this side length across from my 90 degrees, no matter what size it is. It could be like my orange and purple square cut or the green and blue. The value of this side is always going to be x square root of 2. Again, that's the value of this line right here. Alright, let's do an example. If we first are going to label the lengths, we would say that this is an x value, the 5 is equal to an x value, and then this AC is x square root of 2. So if AB is also 5, because those will have to be the same, then AC is that value of x5 multiplied by the square root of 2. Take a minute to review that before moving on. Let's go on to another example. Again, it's a good idea to label the sides knowing the values. This is an X, this is an X, because those are my side lengths. The value across from the 90-degree angle is always equal to an x square root of 2. So how you show this is that 4 is equal to x square root of 2. The 4 doesn't become the x, its actual value is equal to this whole value here. Treat this the same as any trying to solve for the variable, and you divide by what's next to it, the coefficient next to it. A lot of students want to say divided by just 2, but it's dividing by the square root of 2. Now, we have to review our simplifying radicals, in that knowing that this now is the value of x, the 4 divided by square root of 2. To rationalize the denominator, we don't want a radical, so we multiply what's going to make the radicals go away. If you review your algebra, that's square root of 2, square root of 2. That's a value of product of 1. Anything over itself is 1. But if I multiply a square root of 2 times a square root of 2, that's the square root of 4. Well, if we remember, I'll just put it out over here. The square root of 4 is a value of 2. So this becomes 2, and the top, I'm going to turn it around just because you want to keep your whole numbers first, and then the radical. And then this is my value of x. This actually is 4 divided by 2, which is just 2. So your final answer, I put in the box, is 2 square roots of 2. If you used a calculator and just said 4 divided by square root of 2, you'll get a decimal value, which is fine, but I also want to see that we understand how to leave it in simplified form. So AB was a value of 2 square roots of 2, and BC was a value of 2 square roots of 2. Putting our answers over here. Okay, one more. If this is equal to x square roots of 2, then these are my x's. Again, it's always good to label your parts of your 45, 45, 90. All right, so this is what we're looking at to solve for x. So you've got, I'll just write it again over here. X square root of 2 is equal to 3 square roots of 15. We want to divide this by square root of 2. This divided by square root of 2. Again, what am I going to multiply by to get rid of, rationalize the denominator, get rid of that? Would be a square root of 2 on both sides. This again is a product of 1. We're no longer looking at that side of the equal sign because this is what we're solving for, our x. So this is actually going to be square root of 2 times square root of 2 is square root of 4, which is 2. So that on the denominator is just going to be a 2. 3 times, we understand this to be a 1, is just 3. And then this 15 times 2, you multiply what's underneath the radicals together, is 30. Leaving this rationalized, the answer is 3 square roots of 30 divided by 2. And that both sides are that. Both your legs are you. Okay, here's a fraction. It's a little bit different, but it's still going to just do it by step. The value is x square root of 2, whereas this leg and this leg are just values of x. Alright, so we're having to solve what 1/2 divided by square root of 2 is, because we're trying to solve for x, and that is dividing by the same, square root of 2. Again, this goes away, so x is equal to this. And if you did put this in a calculator to get its decimal value, let's just do that for this one. If you've got 1 divided by 2, it's all of this divided by, oh, I needed to put that in parentheses. This is a good lesson to learn. If you keep this in parentheses, then it will actually do the division. It does the order of operation for you. You're dividing the whole 1/2 by the square root of 2. That's going to give you a decimal value of 0.35. Just go ahead and round it to the hundredths place. So 0.35. To rationalize this, however, we have to remember that division of is the same thing as dividing by the multiplying by the reciprocal. So that's actually 1/2 times 1 over square root of 2. To get rid of this, you're going to multiply all of that by square root of 2, so that this is actually becomes 2, because square root of 2 times square root of 2 is square root of 4. So this is actually going to be 2 times 2, which is 4. And then 1 times square root of 2 is square root of 2. If you want to check that, you've got second square root of 2 divided by 4. You'll see that in the calculator you're getting the exact same decimal value. And again, depending on your teacher, she may accept leaving it in decimal form or prefer it in simplified radical form, which is the square root of 2 over 4. But knowing both is important. And that is it for 7-3.